Hi guys, please like, share and subscribe, and contact this number if you want full lectures of any CM or CS subjects. Thank you. Okay, now let's look at this topic. It's related to accumulated values. Again, there's nothing in this if you know the theory well. You just have to apply it in Excel, and that's pretty straightforward. You just have to write the formula using first principles. Okay, so it says a lump sum of 100 is invested at time 0. So at time 0 you have 100. Determine the accumulated value of investment at time t is equal to 1 to 20 years, assuming an interest rate of 3.2% per annum convertible monthly. Right, so let's see how do we do this one. So what's my interest rate? Convertible monthly, right? And it's 3.2%, so I can just write 0.032, right? And let's call it the accumulated value at time 0. Let's just write the present value at time 0. So at t is equal to 0, the value is 100, and I'm just finding the accumulated value at different times. So t is equal to 1, 2. I can just drag this down. So yeah, let me just drag this down up till 20. Yeah, 20 till 20 you want. How long do you want this for? Let's just see. Yeah, till time 20 years and 3.2% convertible monthly. So yeah, this is interest convertible monthly. Now I have two options. Either I can just write the accumulation factor based on this 3.2% convertible monthly, which I will show you, or I can find the corresponding interest rate and write the accumulation factor based on that. So both the options you have, I'll demonstrate both. Okay. So first of all, I'll try to write the accumulation factor based on this figure itself. So how will that work for me? So let's talk about the accumulated value at time 1. Okay, what will it be? It will be 100 into your 3.2% convertible monthly, right? So 0.032 divided by 12 whole to the power of 12 into 1. Next you will have accumulated value at time 2 will be equal to 100 into 1 plus 0.032 divided by 12 whole to the power of 12 into 2, and it will just keep on going. So that's what you need to do. So let me just execute this. So it's just equal to 100, which is right here, multiplied with, I'll just open a bracket, 1 plus 0.032 divided by 12. Okay, so by 12. Okay, whole to the power of 12 times 1. Okay, times 1. Okay, this is what I have got. Yeah, let me put this whole thing in a bracket as well. So let me just say that yeah, let me just put this whole thing into a bracket, which it would look nicer that way. Yeah, so that's how I can do it. Okay, fairly straightforward. Let me just give the answer in terms of maybe, is the currency given here? So I will give the answer in a good way then. If the currency is given, let me just see that if I have the currency. Yeah, it's 100 pounds. Okay, so I'll write up to 2 decimal points and I'll write this in pounds. Let me write this in pounds. So let's just format it. Format cells, currency. Since I'm in India, this is in rupees, but I'll convert this into pounds. GBP. Yeah, Great Britain pounds. Yeah, and 2 decimal points. Okay, so yeah, let's just write GBP only. Okay, So all of these I'll program them to be in GBP. Currency. Don't you have pounds here? POUNDS. GBP. Okay, let's write GBP only. Don't care. Anyway, so this is what you have got. Now you need to convert this formula to all the cells, and what needs to stay constant is B2. So I will put dollar signs in front of B2 as well as B1. The interest rate will be the same. Yeah. And A5, then I'll have A6, A7, so on and so forth. This will keep on changing. Okay. So I can now drag it down to 20 periods. This is the cell size is too small and that's why it's blurring out. So I just need to drag it out a bit. But I think there is some issue with this. That's why the answers are coming out to be a bit weird. Oh, I just need to put this in one bracket, this term, to show that this is in power. Okay. Yeah, I made a mistake here. Yeah, now this is correct. So the mistake I made was that this whole thing, 12 times A5, this whole thing was in the power of this. If you see here in my formula that I've written, see the whole thing is in power. Okay, 12 into 1, 12 into 2. So since this whole thing is in power, so you need to, yeah, you need to put this whole thing in power here, and that's what I've done. And now these values are correct. So that's how you can just, solve this question. This is one way to do this. I'll show you the other way as well, which I'll demonstrate on the other question. Okay. So let me do that one for you now. The other question is 100 is it's the same investment. It's just the discount rate. Instead of interest rate, this time you have got discount rate, which is convertible 6 monthly, and it's at 2% per annum. Convertible 6 monthly, and it's a discount rate. So what I can do is I can convert this into an interest rate, and then I can use that interest rate to find the accumulated values. Okay, so let me see how will I do that. How will I convert this into an interest rate? 2.3% convertible. So I've got discount rate convertible 6 monthly, I guess. Yeah. So D2 is given as 0.023. So obviously I can say that 1 plus I to the 1 plus I is equal to 1 minus D2 by 2 whole to the power of minus 2, right? And using this I can find I. So I will be equal to 1 minus D2 by 2 whole to the power of minus 2 minus 1. Yeah, that's what I'll do. Okay, so let me find this rate first. So again, my t is equal to 0. My principal is the same. Okay, but what is different is my interest rate. I've got the rate of discount rate convertible biannually. Okay, that's what you've got, and that's given as how much? 2.3%. So 0.023. Okay, that's what it is. I can find the corresponding interest rate. So I will find directly. Okay, how will I find that? It will be, I'll just apply this formula. So 1 minus D2 by 2 whole to the power of minus 2. This will be your accumulation factor, and you will just make a minus 1 from this. Yeah, So this is your interest rate, and now you can use this interest rate to find 20 period accumulation. Yeah. So how will I do that? This will be equal to 100 times 1 plus, I'll just put $sign. Okay, I cannot do it. Just let's just put this first, to the power of 1. Yeah. So now, but I need to make B3 and B2 fixed. So I'll just put $signs in front of them, because 100 remains the same and the interest rate remains the same. Okay. Just the period changes. Okay. Right. Period will keep on changing. So it will start with A5, A6, A7, so on and so forth up till A20. So you have your answers. These are your answers. Okay. So that's how you solve this second question. Okay. Now I'll move on to the third one. Okay. Now let's look at this question. Draw a single graph to show the accumulated value of investments at time 0 to 20 with an interest rate of 4.5%, discount rate of 4.5%, interest rate of 4.75% convertible quarterly, discount rate of 4% per annum convertible monthly, force of interest 4.9% per annum. So all of these I need to first plot in a table and then draw a single graph. Okay. I'll do these. I can do these using the approach I used in the first two parts, but I will show you a third approach now, how to do this. Okay. I'm just trying to give you various alternative ideas. So the first one, we just applied the formula directly using the accumulation factor of 3.2% per annum convertible monthly. In the second one, we calculated the corresponding interest rate and then applied the accumulation factor formula. In the third one, I'm going to take a bit of a different approach and look at that. How do I do it? Okay. So yeah, let's enlarge this a bit. Okay. Yeah. So what is my initial principal at time t is equal to 0? I've got 100, and then I have got different interest rates which are operating here. I don't need this thing. Yeah. So yeah. So yeah, I've got 4.5% per annum effective. So interest rate, I'll list all the interest rates. Okay, let's call this interest annual interest rate. Annual interest. What is this one? 4.5% per annum. So 0.045. Okay. Then I've got annual discount rate. Annual discount. This is also 4.5%. 4.045. Then interest rate 4.75% convertible quarterly. So interest quarterly. Okay. 0.0475. Okay, that's what I've got. And then you have got 4% per annum discount rate convertible monthly. So in discount monthly. Okay. And finally force of interest. So force of interest. Okay, so what is this one? This one was 4%, 0.04, and the force of interest is 4.9%, 0.04 and 9. Okay, these are all the ones you have got. Now, what are the periods that I'm working with? 1, 2, 3, 20 till 20. So time is going like this. Okay, and I'm going to call this as A, this is B, this is C. Okay, D and E, obviously. D and E. Okay, that's what I'm going to refer to these as. Let's drag this one down till 20. $19 and $20. Okay. Now how will I work with this? See my approach. I'm using a different one. Let's work under A for once. Okay. Or let me just call these whatever they are as they are named. Okay, so I will just, so I've got annual interest, I've got annual discount, I've got quarterly interest, I've got monthly discount, and I've got force of interest. Okay, all of these, not giving any names. Fine. And so how do I work with this? So let's see what is my initial amount, 100. Okay, now under an annual interest rate, what will happen is 4.5% of interest will apply to it every period. Okay, so I can write it as equal to uh, this initial amount of B1, that is 100, into 1 plus 0.045 to the power of 1. Okay, so yeah, so I can just write it this way. Okay, yeah. In the next period, what will happen is again, so for the first period I've applied 4.5% to this. In the next period as well, I will apply 4.5% to this again, to this sum, to the new principal. So I can write this as equal to this B10 times let me just do one thing to make things very easy for you. I will also include time 0 here. Okay, of this, let's start with time 0, and in time 0 it will always be 100. We'll start with 100. Okay, so this will make life easy. So what we had was 100. Then what we did is, we don't need this B1 thing here, we will start with B10 only. So B10, and this interest rate I'll make fixed so that I can drag this one down. Yeah. So what I did was, I took this initial sum of 100 and I applied this interest rate of 4.5% to it. Okay. Now in the next period, what will happen is, I will take B11, this amount, and I'll apply this 4.5% to it. So what I can do is, I can just drag this one down. Okay. What happened is, B11, and you applied this interest rate of 4.5%, and this I can keep on doing. So you can just drag it down. So instead of, applying our usual formula, what I'm doing is, I'm doing it iteratively. Okay, I am just repetitively applying the interest rate to the previous period's accumulated value. So B11 I've applied, and then in B12 I've applied to the previous one, B11, and then in B13 I've applied to B10, B12, the same interest rate, and it keeps on going. So this makes things very easy. So this is how the first one I did. Now the second one is annual discount. So how will this work? See, you'll need the discounting factor. Let me write that down for you. So what will happen is, your discounting factor will be 1 minus d. This is annual discount to the power of minus 1. 1 minus d to the power of minus 1. This factor you have to apply to each one of them. Okay. So how will that work? So this will be equal to 100 times 1 minus d, annual discount, to the power of minus 1. So to the power of minus 1. Okay, and this is what I have. Yeah. Okay, and I can make this before fixed. Okay, so let's make this fixed by putting dollar signs here. Right, this interest rate will be fixed in all. So yeah, that's what I'm doing. I applied this to C10. Now I can apply in C12. I'll apply to C11. So C11, and now I can just drag this down. So that's how you can do it. This is an alternative approach. Every period's accumulated value, you apply the accumulation factor from the next period too. Now this is quarterly interest rate. So how will this work? This will be equal to D10 times 1 plus I4 by 4. Okay, so 1 plus I4 by 4. So I4 is this, divided by 4. Yeah, whole to the power of 4 times whole to the power of 4. So to the power of 4. Yeah, that's how I'll do it. Yeah. Okay. So this is what my result. And then I can just directly drag it down. There's some issue with it. Let's check what is the issue. No need to panic. We'll just check. So here D10, D11. Okay. I did a mistake here. Obviously, I had to apply the dollar sign to fix the interest rate. So just apply the dollar sign, dollar and dollar. Okay. So now the interest rate is fixed. Every time I'm taking 0.0475. Now you can drag it down. Yeah. So you have your results. Now monthly discount, how will you do this? This will be equal to 100. You have to accumulate using a discount rate. So 1 minus D4 by 4 whole to the power of minus, okay, no, this is monthly, right? So D4 by 12. And obviously you have to apply dollar sign. So I'll just apply that directly before only. Okay. So 1 minus D4, sorry, D12 by 12 whole to the power of minus 12. So minus 12. Yeah, that's how you can do it. Perfect. So this is your answer. And now I just need to drag this down. Since this was monthly. Okay. And this rate is much lower. That's why you're getting much lower answers. This is 4% only. Okay. Finally, I've got force of interest. So how do you do that? That will be equal to 100 into exponential of, let's see if we have got exponential function. Yeah, exponential of 0.049. Yeah, that's how you apply it. And now you can just drag it down. But your B7 has to be constant. So I'll put dollar signs, dollar and dollar. Okay. So you just need to drag this down now. Yeah. Now I need to write all of these in Great Britain pounds. So I'll just convert them to GBP. I'll go to format, cells. These are currency values and I'll use GBP. Enter. So suddenly all of them are in Great Britain pounds now. Now I just need to make a graph of these. So how do I do that? Let's see. So next thing is obviously you need to draw a graph here. So you go to insert tab, okay, and you click on this thing. There's this line or area chart and you select one of these. Okay, select any. Select the first one. Very easy. Now I need to select the data that I'm putting here. So right click and click on select data. Okay. Now it's asking for the data range. So you need to select the whole thing. Okay. Whatever data you've got. Okay. You put in the whole thing. And since this T is your time, so you just need to remove this T from here. You're not plotting T. And on horizontal axis, you need to have T. So I'll just put that there. So just select this T from 0 to 20. Okay. This is your horizontal axis labels. From 0 to 20, I've got this. And yeah, you are done, I guess. So you just need to press OK. And this will give you the graph. Okay, so to say. So this is what your graph looks like. And yeah, chart title you can put accumulated values, just say accumulated values. Add different interest rates. Okay. Yeah, so you just need to put this. And if you need labeling for this chart, I think there are options for that as well. Yeah. So this is your chart. This is how you make it. And I think you can get the labels as well, but I'll have to see how does that work. Yeah, so you need to click on this plus sign and then click on legend. Okay, once you do, you'll get these labels of what represents what. So red one is the annual interest rate, gray is the annual discount, and everything else is labeled already. So yeah, it's pretty much understandable. And yeah, that's how you draw a graph whenever needed. Okay, you just go to insert and just insert a graph from here, somewhere here. Line chart, if you want to put in, you can put in the line chart. Right click, select the data, and then configure the graph as you want to. You can play around with this a little to see how it works. Okay, so yeah, that's all for this video. Okay, thank you.